Okay, so we've gone through some of the Stone Age, we've talked about the Bronze Age that we're going to hopefully come back to, and we've looked at the Iron Age. Now, after the Iron Age, as I was saying, some of our ages are dictated by the technology. So after the Iron Age, there's another age that we get to, which is called the Steam Age or the Industrial Age. So this is when we created fires that were much, much hotter. We were using things called blast furnaces, where we shot oxygen into the fire to get them incredibly hot. But it was still fire which was dictating our technology. So we were getting into the steam age by having fire that was heating water inside a pressurized container, and that was pushing pistons, and that was creating movement. So all of the things that we got from the industrial age and steam age, so Brunel's great ships, the rocket from Stevenson, all these other amazing industrial inventions were again driven by fire. So again, fire is really, really intrinsic in our technology, in our life. So I'm going to show you one of the technologies that came out of this period. So in the mid 1800s, we discovered a material called ferrocerrium. So ferrocerrium relies on a bit of Latin. So Latin is an ancient language of the Greeks, and we use it still today without even realizing it. But ferro in Greek is the word for iron, ferrous, and cerium is the other element that we're going to use to create our alloy, which is cerium. So when we had our steel, we were using an alloy of iron and carbon. When we have our ferrocerrium, we're using an alloy of iron and cerium. So what we're doing is we're doing the same sort of thing. We still want to get those tiny little flecks of iron to ignite in the oxygen in the atmosphere, but if we combine it with cerium instead of carbon, that process becomes a little bit easier and the heat we get from it is a lot hotter. So again, we're using technology to make our life easier, but we're still going back to fire, our most ancient technology that predates even our existence on Earth. So we showed you before about getting some sparks by striking them together. So you can see these little sparks coming off of here, and you can see that I can get my hands fairly close, and if those sparks land on my fingers, there's not enough heat in them to really burn me. Now, if I move forward in technology and I get my ferrocerium rod, you can see some of it's dark and some of it's more shiny. So just like a piece of iron or steel that's rusting, the dark bits is where the oxygen in the atmosphere is reacting and it makes it black. The shiny bits is where I've scratched it, and I've scratched away that coating. So if I keep scratching away that coating, you can hopefully see I can get these sparks and the rod's a little bit more shiny. So I'm doing exactly the same thing. I'm using something hard, just like I'm doing with my flint, to scrape this rod, which has got a mix of iron and cerium. And those sparks, I'm getting a lot more of them, and they're a lot hotter. So to try and show you how much hotter and how much our technology is helping now, I've got a little bit of cotton wool here, so a little cotton bud. I'm going to unroll it so I get a little bit more surface area.
I didn't know they were rolled up.
Oh, there we go.
Learn something every day.
So one of the things that I teach people when I'm talking about fire is about the fire and the fuel. So if you've got a little fire, you need very little bits of fuel. If you've got a big fire, you can have big bits of fuel. So you might have heard earlier in the year the terrible fires that were happening down in Australia. So these were massive fires, incredibly hot, and they were burning buildings, they were melting the tyres on cars, they were burning whole forests. That was a huge, hot, intense fire. So it could burn really big things like whole trees, houses and things. Now, if I put this against a tree and I spark it against a tree, it's not going to set a tree on fire because my fire is very little, so my fuel has to be very little. So what I try and do is get a maximum surface area. So I try and get as much space for my sparks to get onto my fuel as possible. So that's why I've opened up this little bit of cotton wool. So if I try and get my cotton wool and I go back to the Iron Age and I try and get a spark to catch on it, first of all it's very awkward to try and get them in the right orientation and get them on. Let's see if we can get a little bit there. Let's try that one. So it's very hard for me to strike a spark onto it directly. I think, yeah, there's a couple falling on it there, but it's not really doing anything because I'm only getting a very small number of sparks and they're not very hot. So that's why I needed my char cloth to be right next to the flint and it to be a really open material. Now, if I take the new technology and I put it down here, and we get a few, there we go, and we can go straight into a fire on our cotton wool. You can see it burning across the length of the cotton wool. So this is the first time where we got straight into an actual flame. So all the other methods we've shown you, we've got an ember, but this one we've got an actual flame. So if I put that out, I deprive it of oxygen so it can't burn anymore. I'll get another little bit and unroll it. So the great thing about these ferrocerrium rods is I can direct the spark a lot easier. I'm not trying to hit one against each other like this, but I can scrape it right down and the sparks come off the end. I can place my rod exactly where I want it, and those much hotter sparks, and far more of them, fall directly where I want to, and hopefully I can get my fire going straight away. So on top of that, I can put little bits of newspaper, some wood shavings, whatever I'm going to be using as my tinder to build that flame, because you can see, although it's burning, it's going to burn through that cotton wool quite quickly, and there's not a huge amount of heat. I wouldn't want to try and cook myself some dinner on top of that. But that flame I can use to light other pieces of fuel, build the heat, build the fuel. So the larger the amount of heat we get, the bigger the pieces of fuel we can cook and burn. Now, people sort of say, well, ferrocerrium must be a really quite space age material. Is it hard to get? You can get these in camping shops, but ferrocerrium is really common. So next to me here is just a little gas lighter. So on top of here is a little roller ball. So if I spin that roller ball, you can see those sparks. So inside this mechanism is a tiny flake of ferrocerrium. And instead of using a little metal scraper, I can use this little scratched surface on this roller ball. So when I spin that is where I'm getting my sparks. But instead of having a piece of cotton wool to light, inside here is a gas called butane under pressure. So when I push that little lever, the butane rises out of the chamber, turns into a gas, and all it takes is a spark to light my little fire. So the same technology, the same chemistry, the same physics in here is what we're using here. So the ferrocerrium rod, or the gas lighting, sort of cigarette lighter kind of thing, does the same sort of thing.
So if you're in an emergency, you'd be able to use a lighter, even if it was out of fuel, to light something like a bit of cotton wool.
Yep, you should be able to get the sparks off of it. So if I open this up again, let's see how easy it is. There we go.
Yeah.
So a few sparks.
Wow.
And we can burn ourselves away. So yeah, even if your gas lighter's out of gas, you can still, if you've got the right material around. And cotton wool is a real common thing that you have inside first aid kits. If you haven't got any cotton wool, a lot of modern clothing, a lot of outdoor clothing will be stuffed with really light material. So in a real emergency, you make a little rip in your sort of padded coat, pull out some of the lining, pull out some of the stuffing, and it will work just the same as the cotton wool. So hopefully you're going to be able to get a fire going if you really need one. And there we go. So a bit of industrial age fire technology there.
Brilliant. Cheers, Jack.